Here are some examples regarding moving the position of the alkene, as we saw at the end of our alkene chapter. So the first thing we have to notice is that there's, the alkene sort of moved to this position here. And how do we do that? Well, first we need to add something to the alkene that gives us a handle that allows us to sort of migrate the alkene over. And so when I look at this, I see a position where there could be an alkene and then another position. So I think we're going to have an alkene intermediate before we actually get to the product. Really, the only thing we can do with this alkene is to put a leaving group or some functional group on one of the positions of the alkene. This is the most useful position because it gives us some functionality closer to our goal. I could also put something over here, probably a bromine or an OH, but that's not going to do anything for us because that's going further from the goal. So let's focus on this secondary chloride here. How do I do that? Well, it's probably as simple as just HCl. And if I'm lucky, I might even get a rearrangement happening. I'm going to pretend we don't, but it's possible that we get a rearrangement happening and we get the chlorine right there, thus getting us even closer to our goal. But let's pretend that doesn't happen. So how do I get my my alkene, or how do I use this chlorine then to create some product? And we can do an elimination, and I can do an elimination with a small base to give me the Hofmann product, and I can get this alkene to form, right? And then I'm going to move this guy over. And I can get from my new alkene, this one, to the tertiary chloride, again by adding HCl, right? That's going to put the chlorine on the more substituted carbon. And then I can probably get from my tertiary chloride to the desired product by removing this hydrogen. Again, that's going to be an E2 reaction. This is an E2 reaction here. Again, I can probably use the same base, methoxide, a nice small base to ensure that this hydrogen is preferentially removed so that I end up with the Hofmann product. And so we see that it's really just a matter of addition, elimination, addition, elimination. And we just repeat that as many times as we need to get the alkene to move in the right direction. We're going to have to keep track of, do we want Hofmann or Zaitsev products in terms of our elimination? Do we want Markovnikov or anti-Markovnikov in terms of our addition? Here, it's all thermodynamically favorable, so we didn't have to choose any interesting reagents. But in this next one, I think it's a slightly different problem. So the next problem, we have this tri-substituted alkene, and now we have a di-substituted alkene that we want to transform it into. And again, HCl here will give us Markovnikov addition with the chlorine on that tertiary site, which we shared between our two different alkenes. So we know that we're sort of on the right track, and probably just an elimination step here can get us to this di-substituted alkene. And in this case, though, I think we want to attack a less hindered hydrogen, preferentially over this hydrogen, because this one will just lead us back there. And so we need a large, bulky base. And again, you can just draw TU toxide quickly if you need a large, bulky base that will preferentially remove that hydrogen over that one. And that's just going to give us the Hofmann product and undergo this E2. So here we just have an addition and then an elimination to essentially move the alkene from the internal position to the outside position.